Let's continue discussing sensors and actuators. Now we will talk about the types of actuators used in HVAC system. Actuators are small motor devices that use little power to turn HVAC dampers or valves open or close. When you use it with dampers, it controls airflow, and if you use it with valves, it often controls the water flow rate. There are 4 common types of actuators used in HVAC system. Number 1, spring return on-off actuator. 2, air volume modulating actuator. 3, chilled water on-off actuator. And 4, PIV-CV modulating actuator. Spring return on-off actuators are mostly used for the fire and smoke damper in HVAC system. A fire and smoke damper is a piece of damper that has the ability to prevent fire and smoke from passing through. Air volume modulating actuators are used for the air volume control damper and the variable air volume box in HVAC system. Air volume control dampers and VAV boxes are responsible for the supply air and the return air volume control of air handling units and the fresh air and exhaust air volume control of ventilation fans. Chilled water on-off actuators are mostly used for the ball valve and the globe valve of chilled water fan coil units. Together, they control the chilled water flow into the fan coil unit and thus regulating the cooling and the room temperature. Pressure independent balancing and control valves, or PIV-CV. Modulating actuators are used for the PIV-CV of chilled water, air handling units, and fan coil units. As the name suggests, PIV-CVs are pressure independent. Hence, they perform much better when it comes to precision control of chilled water flow. Here is another example of sensor and actuator operation. As you can see, we have a modulating valve actuator installed on chilled water supply pipeline of an AHU system and a temperature sensor at the supply air duct. So let's say our temperature set point is 16 degrees centigrade and the air supply temperature coming out from the air duct is 20 degrees centigrade. Temperature sensor will send an electrical signal corresponds to the temperature that was 20 degrees centigrade to the controller. Then controller will evaluate the actual temperature reading based on temperature set point. So the controller will send an analog output signal to open the valve actuator in a particular percentage to let the chilled water go into the system until it reaches the desired set point that was 16 degrees centigrade. This is Siemens air damper actuator connected to a 24 volts AC power supply. Let us see the movement of an actuator when supplied by power. Actuator moves slowly. As you can see, the voltage signal is increasing. It means actuator is turning. As the actuator turns, a corresponding voltage signal generates. This electrical signal is the signal that controller will evaluate and converted it to percentage. The positioning time of this actuator is approximately 120 seconds, and the signal voltage is 0 to 10 volts, meaning at around 10 volts the actuator is in 90 degrees rotation. So the 90 degrees rotation was completed at 9.87 volts. This is a BMS graphics for air handling unit. As you can see, the temperature set point and supply air temperature are both 15 degrees centigrade. Additionally, the chilled water valve actuator has an 18.7% opening and a 21.3% reading for the feedback signal. The valve actuator is moving back and forth to maintain the proper temperature set point at the time this image was taken. Green color of supply fan graphics and others indicating that the graphics are online. The controls of a building's MEP system can run via BMS without the need for human interaction, as we covered in our earlier discussion of one of the benefits of BMS.